number problems and quadratic equations. So we're about to start solving some problems that require our quadratic equation solving skills to solve them. And so before we get into examples of these types of problems, I just want to sort of go through the checklist of things we're going to do for each of these problems. And this is a good guide to follow in solving any math problem. So the first thing we're going to do is we're going to read the problem and make sure all the words and ideas are understood. Then we're going to identify what it is we're looking for in the problem. We're often asked to find something like find the speed of the river, or find the number of dollars that will satisfy this equation, or whatever it is. And we're going to name that variable. Often it's just x, but sometimes a better letter makes sense. Then what we have to do is we have to translate the problem as we're told it into an equation. And this is probably the key step, translating into an equation. Because if your equation isn't written properly at the beginning, then you're not going to get to the correct solution to the problem. So we're really going to have to concentrate on step 3. So then after the equation has been translated, or I should say the problem has been translated into equation, we just solve it using all those techniques we've been learning. After you have a solution, you check, does that answer make sense given the context of the problem? And finally, answer the question with a sentence. So those are the steps we're going to be following here. In this video, we're concentrating on solving number problems. So number problems are a specific type of problem where you are given some information about a couple of numbers and how they're related, and then you have to set up an equation and solve that equation in order to determine what those numbers are. So this first example is a classic example of a number problem. The product of two consecutive odd integers is 195. Find the integers. So we're just going to go through these steps that we talked about. And step 1 is to read the problem, which we just did, and make sure we understand it. So one key idea that we have to understand is two consecutive and odd integers. So we have two numbers and they're consecutive. So an example of consecutive odd integers would be like 1 and 3. 1 and 3 are consecutive odd integers because 3 is the next integer to come after 1. But another pair would be something like negative 21. And then what would be the next odd integer that's greater than negative 21? So the next number would be negative 20, but that's not odd. So the next number after that would be negative 19. So those are examples of consecutive odd integers. Now, the product of these consecutive odd integers is 195. And 1 and 3 don't multiply to 195. I don't know if 21 and 19 do, but I'm pretty sure they don't because that number would be higher than 195. But we don't want to solve this by guessing and checking. We want to solve it by setting up an equation and then solving that equation. So we've read the equation, we understand it, now we identify what we're trying to find. And we're trying to find the integers, the two consecutive integers. So what we're going to say is that the first number is equal to x. The first integer number that, for example, that would be like 1. If 1 is the first number, we're going to call that x. It's something that we just don't know yet. And then the second number, what's its relationship to x? Well, it's the next consecutive odd number. So if x is equal to 1, the second number is x plus 2, because the next odd integer is 2 away. So again, if we have 1, 2, 3, 4, 5, if we start at 1, the next odd integer is plus 2 away. If we start at 3, the next odd integer is 5 away. So we're saying the first odd integer, we're just going to call it x. We don't know what it is, but that means that the second one is x plus 2. So we have x and x plus 2, and now we have to use this relationship to set up an equation. So step 3 is to translate this into an equation. So we're told that the product of these two consecutive odd integers is 195. Well, the product means multiplication. So the two numbers multiplied together equal 195. So that would be the first number times the second number. So x times x plus 2 is equal to 195. So we've translated our sentence into an equation, and now we solve. So how do we want to solve this equation? The way I see it, let's just multiply the left-hand side out. X squared plus 2x equals 195. And now the easiest thing would probably be to pull this 195 over and see if we can factor. So what I did is I just grabbed a piece of scrap paper and I tried dividing 195 by a bunch of numbers, and I found that it can be divided by 13 and 15, and I think these are going to work for us. So we have to get to negative 195. So if I do negative 13, positive 15, they multiply to negative 195 and then add to positive 2. So I can factor this as x minus 13, x plus 15 equals 0. And so that means that I have two solutions, either x equals 13 or x equals negative 15. These two numbers are not consecutive odd integers. These are both possible solutions for the first number, which means that the second number is 2 greater than each of those, which would be 15, and negative 15 plus 2 is negative 13. So there are two possible pairs of numbers that solve this problem. And so we have to write this as a sentence. So we could say that the consecutive, and you don't have to write a whole paragraph, just a short sentence that answers the problem. So the consecutive integers are 13 and 15 from this first solution, or negative 15 and negative 13 from the second solution. So there's basically a positive and negative solution to this problem. But this is an example of how we'll go about solving number problems. I'm going to go through this next problem a little bit quicker. I'm not going to go through each step in as much detail, but I want to show it to you because it has a trickier equation that we have to set up at the beginning. So start by reading. Subtracting a number from half its square results in 11. What is the number? So first of all, I see what is the number is our question. So the number, we're just going to call that x. What is the number? And now we'll have to set up an equation to solve this. So looking at this sentence, subtracting a number from half its square results in 11. Whenever you see results, think equal. So we have subtracting a number from half its square. So we're going to subtract x from half of x squared. So I could write that as x squared over 2, or I could write it as 1/2 times x squared. But either way, we have to subtract a number, so subtract x from half of its square, and the result is 11. So it's equal to 11. And it's important to note that even though this part came first, subtracting a number comes first. It's actually, the second part of it comes after the squaring and halving of x, because you subtract it from half of its square. So subtracting a number from half its square results in 11. Now we're ready to solve this equation. So we have x squared over 2, or really, I think I will write this as 1/2 x squared so that it looks more like a standard quadratic equation, minus x. And I'm going to say minus 11 equals 0, so move that 11 over. And now I have what's looking like a pretty normal quadratic equation, only that I have a 1/2 in front of the x squared. And I'm going to just multiply everything on each side of the equation by 2 to get rid of that half in front of the x squared term, because that will make potentially factoring or using the quadratic formula a lot easier. So I'm going to I'm going to multiply everything by 2. So 2 times 1/2 leaves me with just x squared. 2 times negative x is negative 2x. 2 times negative 11, negative 22. And 0 times 2 on the right-hand side is still 0. So that's nice. I can multiply by 2, make my equation look a lot easier. Now, to factor this, if I was to try factoring this, negative 22, could I find two numbers that multiply to negative 22 and add to 11? Well, the only number that I know of, the only combos I can think of are 11 and 2 or 22 times 1. And neither of those I'm going to be able to combine them to negative 2 somehow. So factoring is not an option for me. And if factoring is not an option, it means I'm going to have to use the quadratic formula to solve for x. So starting with x equals, we're going to do negative b. So negative b would be negative 2 plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is negative 22, all of which is divided by 2a. Now we'll just simplify what we have. So we have x is equal to positive 2 plus or minus the square root of 4 plus 88, all divided by 2. So that would be 2 plus or minus the square root of 4 plus 88 is 92 over 2. Now there's a good chance that I can simplify that square root of 92, but because the question just asks for an answer rounded to 2 decimal places, then I'm not going to take the time to find that simplest answer. Instead, I'm just going to go ahead and evaluate this using my calculator as 2 plus the root of 92 divided by 2, or x is equal to 2 minus the square root of 92 over 2. Because if we try to simplify it, we're just introducing a step that we could potentially make an error in. So why don't we just instead do this in our calculators and play it safe, since that's all we need in the final answer. So x equals 2 plus square root of 92. So I'll do that step first, and I get 11.59, and then divide that value by 2. So my first solution would be 5.796, which means I have to round up to 5.80 for 2 decimal places. Second solution, same thing, except with a subtraction sign. So 2 minus the square root of 92, I get negative 7.59. Divide that value by 2, I get negative 3.796. So again, round up, negative 3.80. So those are my two solutions, and I'm going to write this as a sentence, but just before I do that, I'm going to do a quick check. If I was to take 5.80, does it satisfy that original equation we had written? So if I take 5.8 and I square it, and then I divide that value by 2, I get 16.82, and then I subtract 5.8 again, I get 11.02. So I don't get 11 like this problem says I should. So by subtracting 5.80 from half of its square, I got 11.02. But keep in mind that this is a rounded answer. So when I plug it back into the equation, I shouldn't expect a perfect result. So the fact that it's at 11.02, I'm very happy about that. And if I did the same thing with negative 3.80, so negative 3.80 squared, and then divided by 2, I get 7.22. And then if I subtract negative 3.80 or add 3.8, then I get, again, 11.02. So it's because we've rounded to 2 decimal places that when you throw it into the equation, you get something very close to 11. If we'd kept a whole bunch of decimals, like 8 decimal places, we would have got exactly 11. So I'm happy with those answers. They make sense. And now I can write my sentence solution. And again, it just has to be short. You don't have to recap the whole problem. So I'll just say the number, remember that's what we were trying to find. What is the number? So the number is negative 3.80 or 5.80. That's a perfectly acceptable answer to that problem.